Hello everyone and welcome back to Newton's Academy past paper review for grade 12. Today we'll be doing a past paper question on electrostatics, and that is this question 8 for physics. So let us get right into it. The question reads, three 100 microcoulomb point charges A, B and C are equally spaced on a straight line in a vacuum. The charges are a distance of 3 centimeters from each other as shown in the sketch below. Okay, so we see we have A, B, and C. They all have the same magnitude. They all have the same sign of charge. They're all positive charges. And A is the same distance from B as C is from B. They're both 3 centimeters away from B. Okay, 8.1 asks, name the law that describes the electrostatic force exerted by one point charge on another. And there's only one law which describes this, and that is Coulomb's law. So 8.1, the answer will be Coulomb's law. Okay, looking at 8.2, 8.2 asks, a learner sketches the electric field pattern produced by three charges as shown below. Write down three mistakes that the learner made. So they're telling you that there are three mistakes that the learner made, and you have to identify those mistakes. So let us see. We're comparing obviously charge A, B, and C. Well, the first major mistake that I notice here is that for the field line of charge B, the field lines cross each other, and that is incorrect because field lines should never touch each other. So that's the first mistake. Secondly, they are all positive charges. So A and B, we see that the direction of the field lines are correct. It's going out. But for C, we see that the field lines are coming in. So that direction is incorrect. So that should go out. Secondly, given that all the charges have the same magnitude, the density of the field line should be identical. And we can obviously see is much less dense compared to A. So that is incorrect. They should all have the same density. So let us write those three reasons down. 8.2. So field lines should have the same density. Secondly, field lines should never touch. And thirdly, we said field lines always move out for a positive charge. Okay, so those are the three mistakes that we can identify which this learner made. Okay, question 8.3. Question 8.3 asks, calculate the net electrostatic force experienced by point charge C. So point charge C is over there. So what we can do is we can quickly draw a free body diagram. Why? Because electrostatic forces, after all, are forces. So they work the same way as which all other forces work, and we can explain them or visualize them using a free body diagram. So these are all positive charges. Positive charges or like charges repel each other. So B will repel C. So we'll have a force of B on C. So we'll call that FBC, right? A force of repulsion. And A will also repel C. A will repel C. So we have a smaller force FA on C, also to the right because it's also repulsion. The reason the force of A on C is smaller than the force of B on C is because A is much further from C than B. Okay, so let us go and calculate the net force. So we said for 8.3, the net force on C is equal to F B on C plus F A on C, because they both act in the same direction to the right. And we know the equation defining the force according to Coulomb's law is KQ or QB rather, QC all over R squared, and KQA QC all over R2 squared. Okay, so substituting values for those, we know K and QC are the same in both cases, so we can actually take that out as a HCF. So K will be 9 times 10 to the power 9, it is a constant, and we have QC, which is 100 coulombs or microcoulombs, and QA and QB are in fact the same as well, so we can take those out as a factor as well. So we have QA and QB, they are the same, 100 microcoulombs, so times 10 to the negative 6, and we have that all going into 1 over R1 squared, which is 3 centimeters, so 0.03 squared plus 1 all over 0.06, because charge A is 6 centimeters away. Okay, and when plugging that into a calculator, obviously if you wanted to, you did not have to take that out as a highest common factor. You could have simply substituted as is. It's just less work when you take out the highest common factor, because you're only substituting those once, and once you substitute those in, you will get your answer to be, your final answer to be 1.25 times 10 to the power 5, and force is in newtons, and we indicate the direction, and that will be to the right. So that is our net force on charge C. Okay, 8.4, write down the net electrostatic force experienced by point charge B. Give a reason for the answer. So it's just telling you to write down, no calculation required. Looking at point charge B, it's in the middle, meaning point charge A and C are equidistant from the charge B, and also point charge A and point charge C have the same magnitude, meaning the magnitude of the forces of charges A and C are equal, and they're in opposite directions, because C repels B that way, A repels B to the right. So the net charge on B will be 0 newtons, and the reason will be because the force of A on B is equal to but opposite in direction of the force of C on B. That will be your reason. So that both forces are equal, they are just exert in an opposite direction, therefore they will cancel out to give you 0 newtons as your net force on point charge B. Okay, and that concludes this question on electrostatics. Thank you for watching.